Alright, so I know we've bounced around quite a bit lately. We went from doing 8.1, 8.2, 8.3, and then we jumped to 9.3, 9.4, and now we're in 8.4. So we're coming back to sine and cosine and their functions. So we're going to learn how we can graph sine functions and cosine functions. And in order to do so, we're going to be graphing in terms of radians. So we'll be graphing with radians. So you can see here that I have this table. So we have x over here. So if x are these values, these are our x values, being in radians. And then if this is our y value, what does sine of x or cosine of x equal? So we're going to fill out this table to help us understand what a sine and a cosine function look like on a graph. So first of all, what we're going to do is, well, for me, I'm going to graph these. So I'm going to make myself a little graph. Remember that on a graph, on a coordinate plane, when you're graphing sine, cosine functions in radians, what we're doing is we are taking the terminal side and seeing how much it rotates. So this green line will be my terminal side. And just as a reminder that this right here is 0 or 2 pi, right? So if my line stays here, it's at 0 pi, but if I rotate all the way around, that is 2 pi. Up here is pi over 2, and if I come over here, this is rotated pi, and if I come down here, this is rotated 3 pi over 2. Alright, so what is the value of sine of x when x is negative 2 pi? So this is sine of negative 2 pi, right? So we are going to see what the value of y is when x is negative 2 pi. So if I come over here, negative 2 pi means I rotate this way and I come right here. So this would be negative 2 pi. So I'm at this point right here, and at that point I have x is equal to 1. How about this? I'm going to label this point as 1 comma 0. Okay, now at this point my x is equal to 1, my y is equal to 0, and my radius is equal to r. So remember that sine of x, so sine is equal to y over r, while the cosine is equal to x over r. So let's remember that. So if my y here is 0, that means sine of negative 2 pi is going to be 0 over 1, which is 0. So when x is negative 2 pi, my function is at 0. Okay, let's go to negative 3 pi over 2. So negative 3 pi over 2 means I go here, here, and here. So this would be negative 3 pi over 2, because negative 3 pi over 2 is the same thing as negative 720. So then right here, this point right here, where it crosses the unit circle, is going to be 0 comma 1, where x is 0 and y is equal to 1 and r is equal to 1. So sine again, sine is y over r, so my y here is 1. So 1 over 1, so it's going to be 1. Okay, now negative pi. Negative pi is rotated from here to here. So at this point right here, okay, now this point right here is -1 comma 0. My x is -1, my y is 0. Since I'm using the sine function, I really only care about the y, so I'm going to have 0 over 1, which is going to be 0. Okay, negative pi over 2. Negative pi over 2 is 90 degrees, negative 90 degrees, so I rotate down there. So it'll be at this point right here, which is -1 comma, 0, 0 comma -1. So my y is -1, and so this would be -1 over 1, or just -1. Alright, now let's do sine of 0. 0 would just be at this point right here. So that's going to be, my y at that point is 0, so 0 over 1, which would be 0. Pi over 2 would give me this point right here. So my y is 1, so 1 over 1, which is 1. And if I go to pi, that's this point right here. My y is 0, so 0 over 1, which would be 0. 3 pi over 2 would be at this point right here. My y is -1, so -1 over 1, which is -1. And 2 pi, which would be right here, where my y is 0, so this would be 0. Okay, so hopefully you guys see this pattern right here, but let's graph it right here. So when we are at -2 pi, so that's right here, my y value is 0. So that's going to be right here. When at -3 pi, my y is 1. So let's see, I'm going to draw this line here to help me draw it straight. So that's going to be right here. When it's negative pi, we're at 0. When we are at negative pi over 2, we're at -1. When at 0, we're at 0. Okay. When it's at pi over 2, it's 1. When at pi, it's 0. 3 pi over 2, it's -1. And at 2 pi, it's 0. So going left to right, let's make a curve. Let's connect these points, but by making a curve, not a straight line. So here, the sine function goes up, but then comes back down, and then comes back up, and comes back down, and then it comes down and comes back up like that. And you can see that it continues this pattern. So if we were to continue moving on in this with this, so it'd be to 4 pi or 5 pi over 2 and something like that, 5 pi over 2 and 3 pi and 6 pi or 7 pi over 2 and 4 pi. We would this sine function would continue making this pattern. So this is the sine function right here. We call it a sine wave because it obviously makes a wavelength. Now let's do the same thing but for cosine. Remember that cosine is x over r, so we're looking at our x's, which would be this value right here, this value right here, this value right here, and this value right here. And so at -2 pi, which would be at this point right here, we would have 1 over 1. Which would be 1. At -3 pi over 2, we would be right here. That would be 0 over 1, which would be 0. At negative pi, we'd be right here. So that's -1 over 1, which would be -1. That's for negative pi. Negative pi halves, which would be right here. That would be 0 over 1, which would be 0. At 0, we'd be right here, so it would be 1 over 1, which would be 1. At pi over 2, we'd be right here, and that's 0 over 1, so we'd have 0. At pi, it's negative 1, so negative 1 over 1, so negative 1. 3 pi over 2, which would be 0. And then at 2 pi, we'd be at 1 over 1, so 1. So let's plot these points down here. So when we're at negative 2 pi, we're at 1. Let me just draw these lines. Okay, so at we'd be at negative 2 pi, we'd be at 1. At negative 3 pi over 2, at 0. At negative pi, we'd be at negative 1. Negative pi over 2 would be at 0. At 0, we'd be at 1. At pi over 2, we'd be at 0. At pi, we'd be at negative 1. 3 pi over 2 would be at 0. Okay, so hopefully you see this pattern. We're starting up, we're going down and up and up and down, so like that. So that must mean that this point has to be right here. And so our cosine function will look like this. There you go. So you can see that our function stays between the y values of negative 1 and 1 for both the sine and the cosine function. Okay, so this is how we draw our sine and cosine functions. Now let's look at some of the characteristics. Now this right here, notice that this is our max value, our max y value, and this is our minimum value or minimum y value. It's between negative 1 and 1. So I say that just a little bit earlier. Okay, so our values are between these two y values. Because these are waves, waves are associated with amplitude. So the distance from the maximum value to the minimum value, or not to the minimum but to the x-axis, this is called the amplitude. So amplitude is just the distance from the x-axis to the top of the wave, and amplitude is always absolute value. Okay, absolute value. So we actually just say amplitude is absolute value of A. So that is amplitude. Next, what we have, so you notice that that this works in cycles. These waves are in cycles. So meaning that starting at the origin for the sine function, you're at 0. Now to get all the way back to 0, or to go through one full rotation, you come up and down and up, and that's where you start over again. This is one cycle, or in other words, we call this the period of the function. So the distance from here to the point where it starts over, this is called the period of the function. So in this case, the period of this function is 2 pi. It has to go over 2 pi units to make one full cycle, or to go through one full period. For the cosine, it's also 2 pi, it just starts differently. So here it starts up at the 1. Now to go through one full cycle, it has to go down and up again. And so right here, this is your period, and you can see here it goes from 0 to 2 pi until it starts over again. So for this particular function, the period of cosine and period of sine is 2 pi. So that is what you call the period of the function. Okay, so let's make note of that. So amplitude is equal to the absolute value of A. And A is your distance is the distance from the x-axis to the min or max. But again, it's the absolute value. So right here, if I were measuring from the x-axis to the minimum, that's obviously -1, right? So we would say absolute value of -1, which is equal to 1. So amplitude we always state as a positive number. So that's the amplitude. And then the period is, I guess what it means, it's like the how long, or the cycle, the horizontal length. We'll call it the horizontal length. The horizontal length of each cycle. I guess you could say the cycle, and then the cycle. Cycle means how long it takes for it to repeat its pattern. Cycle is how long it takes to repeat the pattern. And you can calculate the period. I didn't even spell it right over here, sorry. You can calculate the period by using 2 pi over b, and I'll show you what b is. I should have made more space, so hopefully you guys still have some space, but amplitude and periods are actually just basically what they are stretches and shrinks, horizontal and vertical stretches and shrinks. So for example, if we have y is equal to a sine of bx, the parent function of the sine function, or if we have y is equal to a cosine of bx, you can see here that multiplying sine and cosine by a on the outside, so not multiplying x, this is a vertical stretch or a shrink. So this is a is your amplitude, right? So vertical stretches and shrinks are always how long you are stretching the graph vertically. Okay, so we could say if a was 2, we would be stretching this by a factor of 2, which means our amplitude would actually go up 1 more unit all the way to 2. And then b would be what multiplying x by b. We've learned this all along throughout all the times we've talked about transformations of functions, but if you multiply the x of a function, so if you multiply the input of a function, this is a horizontal stretch or shrink by a factor of 1 over b. So that's why whenever you calculate the period, that this value here, b, affects how long the cycle. It might shorten or it might lengthen the period of your function. Okay, so let's come down here and graph. So identify the amplitude and the period of these functions. So we want to identify the amplitude and we want to identify the period, and then graph it and describe its transformation. So so you notice the amplitude, so a is equal to 4. So this is our amplitude. Our amplitude is going to be 4. A is going to be 4. The period, so remember that the function takes on the form y is equal to a sine of bx. So notice that we don't have a value, we just have 1x, and so our b value is 1, so b is equal to 1. So the period is 2 pi over b, which is 1, which is equal to 2 pi. Okay, so 2 pi, this is important for you guys to find the period, because the period will tell you how many where to begin your cycle, or how long your cycles are going to be. Okay, so if I'm going to graph this, now we're going to be graphing in term with x values being in pi halves. So like right here, I'll call this pi over 2, and this one right here I'll call pi, and this has to be 3 pi over 2, and this would have to be 2 pi. So basically, each one is going to be a pi half. So this section here is pi half, and this one's going to be a pi half. Now pi half plus a pi half is 2 pi, or yeah, 2 pi. So yeah. Whoops. Okay, so now let's go ahead and graph this. So the reason why I graphed out a 2 pi is because that's how long my cycle is going to be. So basically from here to here, my function has to make one full cycle. Now the sine function starts at the origin. Okay. Now my amplitude is going to be 4. So 1, 2, 3, 4, 1, 2, 3, 4. Meaning that my function is going to stay in between these. My max and my min values are there. Okay, and so if you guys remember from our activity up here, at pi halves it's at 1, at pi it's at 0. And so honestly, you just have to remember that pattern, and then you can graph it. So it's going to be here, it's going to come down back here, right here, and right there. And it will continue that pattern, just like that. So there you go. There is your sine function right here. Let's come down here and see what we have down here. So notice that we have a b value. So the amplitude is going to be 1. So a is equal to 1, which means our height is going to be from the x-axis to the min and max, it's going to be a distance of 1. The period is going to be, it's always 2 pi over b. Now b in this case is 1, so b is 2. So that means our period is going to be 2 pi over 2, which is equal to pi, meaning that the distance for this sine function to make a complete cycle is actually just going to be 1 pi instead of 2 pi. So what that means is, so you see here that we made one full rotation at 2 pi. But here we have to make a full full cycle by the time we get to pi. So you can see here that this shortens our wavelength. So that's why we get the horizontal shrink. So actually, that being said, we forgot to list our transformations here. So because we multiplied by 4 right here, because the amplitude is 4, then we had a vertical stretch by 4. And that was it. Now here we have a so b is equal to 2, so this is actually going to be a horizontal shrink by 1/2. So remember, horizontal stretches and shrinks are always by a factor of the reciprocal. Okay, and you can already see the shrink. So because we have to make a full sine rotation by the time we get to pi, you can see that we've shrunk the function. Okay, so if I'm going to do this, I'm going to actually count by pi over 4. So I'll say that this is pi over 4, and this is we'll say this is 2 pi over 4, which is basically which is pi over 2, and then we'll call this 3 pi over 4, and this one we will call pi. So each section is a fourth of a pi. So a fourth of a pi, 2/4, 3/4, 4/4. And then we'll call this 1 and we'll call this -1. So the sine function starts here. And so I've already marked, I'm counting by fours is because I know, as we've shown you here, is that we go 1, 2, 3, 4, right? That's how I remember it. So we go up, and we'll be right here. And then we have to come back through to our x-axis. And then we'll probably be about right here. And then we have to come up for pi. So there's one full cycle. So there's our period. Okay. Now let's come down here. So you see that we're multiplying by 4, so our amplitude is going to be 4. And then our period has to be 2 pi over b. b in this case is equal to 2 pi. So this is going to be 2 pi over 2 pi, which is going to be 1. Alright, so our function is going to reach a cycle after 1 unit. After 1 unit, we're going to have a full cycle. Okay, so that means for me how I want to do this, I'm going to count by a fourth. So I'll call this 1/4. I will call this 1/2. I will call this 3/4. And I'll call this 1. And I'm going to have an amplitude of 4. So 1, 2, 3, 4. Call that 4. 1, 2, 3, 4. This -4. Okay, so I know I'll be here to here, 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 and here. Okay, there you go. Should be pretty straightforward. And the transformations here was a vertical stretch by 4, and it was a horizontal shrink by the reciprocal of 2 pi, which would be 1 over 2 pi. So vertical shrink by a factor of 1 over 2 pi. Alright, let's come down here and do some cosine functions. So here's our function right here. Identify the amplitude and the period and describe its, we'll graph it and describe its transformation. So the period, or the amplitude, so we're multiplying it by 1/2. So that means it's going to be 1/2. That's our amplitude. Cosine is 2 pi. So if b is equal to 2 pi, period is 2 pi over b. So 2 pi over 2 pi. So our period is just going to be 1. Alright, just to kind of let you guys see how the graph can continue, I'm going to call this a fourth. I know I'm writing small, but I know I'm going to, that's alright, I'll write a little bit bigger. So I'll call this one 1/4, I'll call this one 1/2, 3/4, and 1, and then I'll call this 1.5, and I'll call this 2. And then our amplitude is 1/2. So I'm going to call this 1/2. So this would be a fourth, this would be a fourth, this would be 1/2. So that is the height of our function. So for the sine function, or for the cosine function, remember that we start up here. So for the cosine function up here, we started on the y-axis up at the top of we started at our max value. Started at our max value rather than in between our max and our min like the sine function does. And so if we start up here, to make one full rotation, that means we have to be back up here at 1 because that's our period. So we come down here like that, come through like that, and then if we continue this pattern, just come down like this, and then this is what a cosine wave would look like, and it would continue that pattern. So the transformations here is a vertical stretch by 1/2 and a horizontal shrink by 1/2 pi. Alright, now I want to give you guys some practice on your own, so I recommend that you guys try these ones out on your own. So again, cosine and sine functions are pretty much, they're the same thing, just like sine functions again start in between your max and your minimum value, while the cosine function just starts at your max value. So that means by the time you make one full rotation or one cycle, you're back at your max value. The sine function, though, starts in the middle, so whenever you make a full cycle, it'll be back in the middle. So that should be pretty much the same thing. You can calculate the period and the amplitude just the same way. Okay. But yeah, that should pretty much do it for this section right here.